So, student, in previous class, we have discussed about some important questions of heat and thermal properties of matter. Now, some other important question of thermal properties of matter are: question first, pendulum clock. Pendulum clocks generally go faster, generally go faster in winter and slower in summer. Why? So, we know that the time period of pendulum is 2 pi under root L upon G. So, time period of pendulum is time period of pendulum is T equal to 2 pi under root L upon G. Now, in the linear expansion, we have discussed that according to linear expansion, according to linear expansion, uh, L dash is directly proportional to change in temperature, or L dash is directly proportional to original length. And you can say that delta L means change in length is directly proportional to original length, and change in length is directly proportional to change in length is directly proportional to original temperature. So what happens in this, that if we increase the temperature, so length will increases, and if length will increase, so the time period of the simple pendulum is also increases. That means in summer, if the temperature is increase due to expansion in length during the summer, time period increases, or the clock loses the time in summer, and in winter due to fall in temperature, the length contracts and the time period decreases. Okay, hence clock gains time. So due to expansion in length during summer, as in summer time, temperature will increases, so that's why its length will be expand, time period increases, time period increases, or the clock loses time in summer. In winter, due to fall in temperature, the length contracts and the time period decreases. the time period decreases, and hence clock gains time. Clock gains time. Okay, now that was our question. Now next question is, two identical rectangular strips, two identical rectangular strips, one of copper and one of copper and the other of steel. The other of steel are riveted together. Riveted means soldered together. Riveted together to form a compound bar. To form a compound bar. What will happen on heating? What will happen on heating? So the answer of this question is, one bar is of copper and one is of steel. So this is the bar of the copper and this is the bar of steel. Exactly. We have seen in our class a concept of bimetallic strip. So they also became a bimetallic strip. What is bimetallic strip? It is also known as the thermostat. And what is the work of it? It is used in electrical appliances like fire alarm, etc. Electric well, etc. Thermostat, geyser. It is used. It is used as thermostat in electrical appliances. In electrical appliances like electric iron, geysers, refrigerator, etc. Refrigerators, electric oven, fire alarms, etc. And what is a bimetallic strip? It is the use of bimetallic strip. Bimetallic strip, a bimetallic strip is made by riveting. Riveting means soldering two metal strips two metal strips of different material of length of different material of same length, different material of same length. Generally, the metal will be used are steel and brass. One is of brass and another is of steel. Suppose this is a steel and this is brass. What will happen in this? That alpha of brass, that means coefficient of linear expansion of brass is 19 into 10 to the power minus 6 per degree Celsius, and the alpha of steel is 11 into 10 to the power minus 6 per degree Celsius. So what happened in this, on comparing, the alpha of brass is greater than alpha of steel. That means expansion in brass is more than the expansion in steel. So what will happen when we increase the temperature of the bimetallic strip? When we increase the temperature of bimetallic strip, normal is brass and what is it? Steel. So what will happen? It will bend on heating because the expansion in brass is more than the expansion in steel, because the coefficient of linear expansion of brass is more than the linear expansion of steel. That's why when it was heated, so alpha will bend more and steel will bend less. So this will be the condition comes that brass will bend more and steel will bend less. So how this work in the fire alarm? Suppose this is used in a fire alarm. So what will happen? This is the metal of steel, this is the metal of brass. When in a room or in anywhere the fire uh, will be flamed, so what happen? This bimetallic strips bends toward like that, and if it touch here, so the alarm rings. So this is the use of the bimetallic strip. Okay, when the fire will be loose, means when the temperature will be loose, so it will come to the normal position. So this is the bimetallic strip, means two metal are repeated together, and when two metal of different alpha or coefficient of linear expansion are repeated together, so when we increase the temperature means where the body will become hot. So what will happen? They will bend. The body in which coefficient of linear expansion is more will bend more, and the body in the sorry the metal in which coefficient of linear expansion is less bend less. So this is a metallic bimetallic strip. Here in the question, this is also discussing a bimetallic strip. This is steel and this is copper. Okay. So what happened in it? Two similar strip, two similar strips of copper and steel are riveted side by side, are riveted side by side as a compound strip called bimetallic strip. As a compound strip is called bimetallic strip. It is straight at ordinary temperature. It is straight at ordinary temperature when the bimetallic strip is heated. When the bimetallic strip is heated, copper expands more than the steel. Copper expands more than the steel more than the steel because alpha of copper, then coefficient of linear expansion of copper is greater than the alpha of steel. So it bends with copper on convex side. Copper on convex sides when the bimetallic strip is cooled below low temperature. Below low temperature, copper contracts more than steel. Copper contracts more than steel. Copper contracts copper contracts more than steel and it bends with copper on concave side. With copper on concave side. Concave side. Bimetallic strip. Bimetallic strip is used in a refrigerator, automobiles, etc. Sorry, refrigerators, geysers, fire alarm, etc. Fire alarm, etc. So what will happen in bimetallic steel? Suppose this is the strip steel and this is the strip of copper. So when we heat it, the alpha of copper is greater than the alpha of steel, so it bend in the convex. So it bend in the convex form. That means this is the bend in copper because the alpha of copper is higher than the alpha of the steel, and this is steel, this is copper. So when we increase the temperature, so convex is bend in the convex. Copper is bend in the convex form, and when we decrease the temperature, so what happen? Copper contract more than steel. So the diagram will be there. Copper and steel. When we decrease the temperature, so copper contracts more than the steel. So this is the rectangle steel. Next, long short answer type question is your next previous year question is explain Celsius and Fahrenheit scale of temperature. Celsius and Fahrenheit scale of temperature. Fahrenheit scale of temperature, obtain a relation, obtain the relation between Celsius and Fahrenheit scale of temperature. Fahrenheit scale of temperature. I have discussed this topic many times in the class. The in previous question you have also seen that the upper point, upper fixed point or lower fixed point of Celsius scale and Fahrenheit scale. And now you will see in this question the relation between the temperature conversion of one scale to the another scale. Now, firstly, we describe about the Celsius scale. That what is Celsius scale? First is Celsius or centigrade. Both are the name of centigrade scale of temperature. Scale of temperature. So in the Celsius scale, in the Celsius scale of temperature, the lower fixed point, the lower fixed point is called the ice point. Is called the ice point and is assigned the value at 0 degree Celsius. And the upper fixed point, the upper fixed point called the steam point, assigned at the value at the value of 100 degrees Celsius. And how many part in this scale? 0 degree, 100 degrees Celsius minus 0 degrees Celsius. So there are 100 equal part in scale. Okay. Means the scale is subsequently subdivided into 100 equal parts, into 100 equal parts, and each part represent 1 degree Celsius. Each one corresponding to 1 degree Celsius. Corresponding to 1 degree Celsius. And now same Fahrenheit scale means in which upper fixed point is at 212 degree Fahrenheit and lower fixed point is 32 degree Fahrenheit, and one part and there are equal to 212 minus 32, that means 180 part, and each part represent 1 degree Fahrenheit. So Fahrenheit scale of temperature. In the Fahrenheit scale of temperature, in the Fahrenheit scale of temperature, the lower fixed point, the lower fixed point is the ice point and in assigned to the value and is assigned a value 32 degree Fahrenheit and the upper fixed point and the upper fixed point is the steam point is the steam point and is assigned at a value 100 degree Fahrenheit. The interval between each point, the interval between each point is 212 minus 32. That means 180. So the scale is divided into 180 equal parts, each one corresponding to 1 degree Fahrenheit. Each one corresponding to 1 degree Fahrenheit. Okay, so this is the Fahrenheit scale of temperature. Now see the temperature conversion. We know the formula of temperature conversion that when one scale is converted into another scale, the formula for that conversion is temperature on a scale temperature on a scale minus lower fixed point upon upper fixed point minus lower fixed point on that scale. Lower fixed point on that scale. And next is equal to temperature on another scale. Temperature on another scale minus lower fixed point of that scale upon upper fixed point of that scale minus lower fixed point on that scale. Okay, so the temperature conversion of various scale are, suppose the temperature is degree Celsius. Temperature on a scale is degree Celsius minus lower fixed point of degree Celsius is 0 degree Celsius. Upper fixed points of degree Celsius scale is 100 degree Celsius and lower fixed point is 0 degree Celsius. Same in the Fahrenheit scale. Upper fixed point is degree Fahrenheit minus lower fixed point is 32 degree Fahrenheit upon upper fixed point is 212 and lower fixed point is 32. Same in the Kelvin scale. Kelvin scale has upper fixed point is Kelvin, lower fixed point is 273.15 Kelvin, and upper fixed point is 373.15 minus 273.15. In Reaumur scale, lower fixed point is at 0 degree Reaumur and upper fixed point is 80 degree Reaumur and 0 degree Reaumur. Now, if you compare first two, because in the question we have asked question has asked that obtain the relation between Celsius and Fahrenheit scale. Okay, so degree Celsius upon 100 equal to degree Fahrenheit minus 32 upon 180. Now, if you cancel, so you will get the value 5 and 9. So degree Celsius is equal to 5 upon 9 times of degree Fahrenheit minus 32. Okay. So this is the relation between degree Celsius and degree Fahrenheit. Now your next previous year question is define Absorptive power. Define absorptive power of a body. What is the absorptive power? What is the absorptive power of a perfect black body? Of a perfect black body. Now the answer of this question is absorptive power. Firstly, we have to define the absorptive power. So, at a given temperature and wavelength, with a given temperature and wavelength, the ratio of the amount of radiant energy, the ratio of the amount of radiant energy absorbed to the radiant energy absorbed to the amount of radiant energy absorbed to the amount of radiant energy incident in a wavelength range is called the absorptive power of a body. Range is called the absorptive power is called the absorptive power at a given temperature and wavelength at a given temperature and wavelength at a given temperature and wavelength. Simply, the absorptive power is defined as the amount of energy radiated upon the amount of energy absorbed to the amount of energy emitted. This is known as the absorptive power of a body. Now, the absorptive power of perfectly black body is always one. Absorptive power of perfectly below of a perfectly black body is one. Now the second question is the roof of building are often painted white during the summer. Why? The of painting the roof of building the roof of building are often painted are often painted white during summer. Why? White during summer. Why? We have seen this concept in the class that the black body is perfectly absorber. Okay, that means they absorbs mostly the light rays of any wavelength set on it, and the white color is known as the good reflector. Black color is a good absorber and white color is good reflector. So that's why the roof of a building are painted white during the summer. Okay, so the main reason is that they will reflect all the heat coming from outside to inside in the house. So the roof of building are painted white during the summer, are painted white during the summer, white during summer, because it reflects, because it reflects more heat radiation, more heat radiations, and absorb less heat radiation, and absorbs less heat radiations, less heat radiations. Hence, we feel comfort inside the house. Hence, we feel comfort inside the house. That's why it's used. Next, next question is short answer questions. Uh, why the gaps? Why the gaps are left between rails on a railway track? Rails on a railway track. Now you have seen in the railway track that these are the two tracks and they are attached to a small iron strips. Why they are attached and why there gap between them? Because in summer, what happen? The temperature increases, and if we increase the temperature, their length is also increases. That's why there are some gap left between the rails on a railway track. Okay, so the reason is the length of the rail increases. The length of the rail increases in summer due to high temperature. Due to high temperature. Therefore, a gap is left between a gap is left to allow the expansion allow the expansion of this expansion. Okay. Now, next important question is why do liquids why do liquids have no linear and areal expansion? Have no linear and areal expansion. Areal expansion means superficial expansion. No linear and areal expansion. So the answer of this question is liquid occupy the same shape of vessel, the same shape of vessel. So they do not have individual length and area. Hence, liquid have no linear and areal expansion. Well, because liquid occupy the same shape of vessel, they do not have a fixed area. That's why they do not have any linear or areal expansion. But liquid have volume, fixed volume. That's why they have only volumetric expansion. So liquid occupy the same shape of vessel. They do not have individual length and area. They do not have individual length or area. That's why they do not have linear or aerial expansion. They do not have linear or aerial expansion. Linear and aerial expansion and aerial expansion. Now the next question is why utensils? Why utensils are coated black and why the bottom of why the bottom of the utensils are made of copper are made of copper. So first is why utensils are coated black. They are coated black because black is a good absorber of heat, and the bottom is made up of copper because copper is a good conductor of heat. So copper is used at the bottom to absorb more and more heat. Okay. So first is utensils are coated black because utensils are coated black because it is a good absorber of a heat. It is a good absorber of a heat. It is good absorber of a heat. And copper is a good conductor of heat. That's why it is used at in the bottom. Heat and copper is a good conductor of heat. Is a good conductor of heat. So copper is used at the bottom. Copper is used at the bottom of cooking utensils. Cooking utensils. Okay. Next previous year question is ventilators are provided in room are provided in rooms just below the roof. Just below the roof. Below the roof. Why? So suppose this is the room. Only roof. So this is the roof of room. Ventilator are provided just below the roof. That means like that. Why they are provided and just below the roof? Because we have discussed in previous class that there are three types of process. First is conduction, second is convection, and third is radiation. Conduction is the process when there will be a transfer of heat without the actual movement of the particles, and convection is the process in which there will be a transfer of heat with the actual transfer of the matter, and the radiation is the process in which the heat does not require any material medium or any intervening medium from traveling from one place to another place. So in the convection we have seen that the colder particles, the particles of the cold gas are lower, and the particle of hot gas are come upwards. So come upwards, because if we increase the temperature, their kinetic energy increases, and if the kinetic energy of the molecule increases, they become lighter. Okay, that's why they come in the upper surface. So same in the room, ventilator and AC are provided just below the roof, because the hot air is come upward in the room. So that's why they may escape through the ventilator, and the cold particle settle down in the room. Okay, that's why ventilator are provided. This is also an example of convections. So the answer of this question is ventilators are provided in room just below the provided in room just below the roof, because hot air escapes out, and fresh air enters into the room enters into room due to convection due to convection. Okay, now next question is, what is greenhouse effect? What is greenhouse effect? And explain global warming. Explain global warming. Global warming. Yeah. So greenhouse effect is an effect when the earth receives sunlight, it get heated up with and emitted various radiation. This is known as the green and infrared radiation into air. So this is known as the greenhouse effect. Greenhouse effect is when the earth receives sunlight, it gets heated. It gets heated up and and emits infrared radiation into air. Infrared radiation into air. CO2, CH4, N2O, O3, and chlorofluorocarbon called greenhouse gases present in air present in the air absorbs the heat content absorbs the heat content of infrared radiation and keeps the earth warm and keeps the earth warm. This is called greenhouse effect. This is called greenhouse effect. Greenhouse effect. Okay. Next is global warming. Global warming. As CO2 content increase, as CO2 content increases, more heat is retained in the atmosphere, and the temperature all over the world increases. And the temperature all over the world increases. This is called global warming. This is called global warming. This is called global warming. So, student, that are some important questions of heat and thermal properties of matter that came in your previous year. Previous year. Okay. So that's all for today. In next class, I will discuss about the chapter thermal properties of matter. Okay.